Good evening everyone. Welcome to Physics Master G class. So here is the GTM 10th paper analysis. There are two questions from this modern physics. So one is from atoms, one more is from photoelectric effect. And thermodynamics nunchi two questions. One is from thermodynamics and other one is from KTG. Moving charges and magnetic effects of currents nunchi two. Electrostatics nunchi two questions. Work per energy nunchi two. One is on the banking, another one is on this momentum and kinetic energy relation. One more is from fluid mechanics, so that also shares two questions. So one is surface tension and excess pressure, right? And EMI nunchi two questions. One is induced EMF and other one is energy, right? So move to the first question. The first question is this: atoms. The shortest wavelength associated with Balmer series is. So we have to take this R is equal to 1.1 into 10 power 7, right? So in this spectra series, ఏ లైన్ అయితే షార్టెస్ట్గా ఉంటుందో ఆ లైన్కి వేవ్ లెంత్ ఎక్కువగా ఉంటుంది, ఏ లైన్ అయితే ఎక్కువ లెంత్ ఉంటుందో ఆ లైన్కి వేవ్ లెంత్ అనేది తక్కువగా ఉంటుంది. సో క్వశ్చన్లో ఈజ్ ఆస్క్డ్ అబౌట్ దిస్ షార్టెస్ట్ వేవ్ లెంత్ ఆఫ్ వార్మర్ సిరీస్. సో షార్టెస్ట్ వేవ్ లెంత్ కాబట్టి వీ హ్యావ్ టు టేక్ దిస్ లాంగెస్ట్ లైన్. సో లాంగెస్ట్ లైన్ ఎక్కడి నుంచి ఎక్కడ దాకా ఉంది? ఫ్రమ్ ఇన్ఫినిటీ టు 2 ఉంది, రైట్? సో therefore this highest orbit will be like infinity and the lowest orbit will be like second orbit. So therefore the wavelength formula is, therefore you could say the wavelength is 1 by lambda equal to r z square 1 by n1 square minus 1 by n2 square, right? Ikkada n1 is nothing but lowest orbit and n2 is nothing but highest orbit. Therefore 1 by lambda is equal to r z square. So 1 by n1 square can be written as, so 1 by lowest orbit is 2, so therefore 4 minus 1 by this is infinity, right? Therefore I could say 1 by lambda will be equal to r by 4 because the z value is 1 because of this is hydrogen, so r by 4. Therefore this lambda is equal to, if I reverse it, that will be equal to 4 by 1.1 into 10 power 7. 1.1 into 10 power 7, therefore sorry, it is 7 only. 1.1 into 10 power 7, therefore lambda is equal to that value. If you do this calculation, you will get it as 3636 angstroms, right? That is answer for this question. So please keep this formula in your mind, remember this formula for the next exam. This 1 by lambda is equal to rz square into 1 by n1 square minus 1 by n2 square. అండ్ ఇక్కడ వన్ మోర్ థింగ్ కూడా గుర్తుపెట్టుకోవాలి, దట్ ఈస్ షార్టెస్ట్ లైన్ ఉంటే లాంగెస్ట్ వేవ్ లెంత్ ఉంటుంది, లాంగెస్ట్ లైన్ ఉంటే షార్టెస్ట్ వేవ్ లెంత్ ఉంటుంది, రైట్? సో క్వశ్చన్ నెంబర్ 2, 1 second. Question number 2. The work done by the gaseous system in going through a cyclic elliptical process shown in the figure is. So this is the PV diagram, right? The area under PV diagram will be work done. So please make a note of it. Area under PV graph. Area under PV graph is equal to work done. Area under PV graph will be equal to work done, right? Area under PV graph will be equal to work done. So here what is the area here? Since it is elliptical process, area can be written as, this area is equal to pi into AB. Area equal to pi into AB and this area is equal to pi here, right? And this A is nothing but semi major axis and B is here semi minor axis. So semi major axis, this is a major axis and semi major will be like, this will be like 20. 20 is a major axis and semi major will be equal to what? That is 20 means this is 10. So this is into kilopascal 10 power 3, right? And semi minor is, this is difference between these two, 20 minus 10, that will be 10 only, but we have to take semi minor, so 5. It is in later, so 5 into 10 power minus 3. So this 10 power 3, this 10 power minus 3 will be cancelled. Therefore this A is equal to 50 pi. A equal to 50 pi, or you could say that area under this PV graph will be equal to work done, that can be written as 50 pi joules. Now there is a question that whether it is a plus 50 or minus 50, right? సో ఇప్పుడు ఇది +15 లేకపోతే -15 అంటే, సో హ్యావ్ ఎ లుక్ హియర్. ఇఫ్ యూ జస్ట్ రివర్స్ దిస్ గ్రాఫ్, మీన్ లైక్ ఇఫ్ యూ కన్వర్ట్ దట్ ఇంటూ పీవీ, ఎక్స్పెన్షన్లో ఎక్కువ ఏరియా కవర్ చేస్తుంది, కంప్రెషన్లో తక్కువ ఏరియా కవర్ చేస్తుంది, రైట్? ఎక్స్పెన్షన్లో ఫ్రమ్ హియర్ టు హియర్ ఇట్ ఈస్ ఎక్స్పాండింగ్, from here to here it is expanding. So if you consider this area, this area will be more. Expansion లో ఉన్న ఏరియా ఎక్కువ ఉంటుంది కంపేర్డ్ టు ద కంప్రెషన్ లో ఉన్న ఏరియా కంటే, therefore that will be like positive. ఎక్స్పాన్షన్ ఎక్కువ ఉంది, కంప్రెషన్ ఏరియా తక్కువ ఉంది కాబట్టి you could say that is a +50 pi j, right? And here also have a look. For example, if it is P here, it is V here, and it is a P here, again it is V here. Clear? So area under this PV graph will be work done, but that work done is positive or a negative. So have a look here now. Here is a volume and here is a volume, right? Let's say this is a V1 and let's say this is a V2, and you could say this V1 is less than V2, right? So now have a look here. Compression low ikkada, this process is compression because the volume is decreasing. This process is expansion because the volume is increasing. So compression low ikkada area ekku undi and this expansion low area takuga undi, therefore here the work done will be negative, right? And have a look here, again the same, similar to the previous one. This is V1 and this is V2. Again you could say this V1 is less than V2, but here this is expansion and this is compression. So expansion low cover chesna area under this expansion graph is more compared to area under this compression, therefore here this area will be positive. Clear? So please keep all these logics in mind for your next exam. So please keep it in mind. Area under this PV graph will be equal to work done, and when it will be like positive and when it will be like negative. So explain here very clearly. If you have any queries or any corrections, so please comment, right? I will give the reply to your comments. Either doubt unna you can comment, so I will give you the reply, right? Moving to the next question. The next question is this one. The electric field of a electromagnetic wave is given by this E is equal to 100 sin omega of t minus x by v Newton per coulomb. Find the energy contained in hypothetical space of volume 100 centimeter cube, right? So therefore energy here, this energy here, energy formula. One second. So since energy formula, this energy can be written as, or energy density can be written as, of energy density of this electromagnetic wave can be written as of into epsilon naught into, you could say this can be written as E square, or you could say this E naught square. Therefore this energy density can be written as energy by volume. Energy density will be equal to energy by volume avutundi. So of into epsilon naught into E naught square avutundi, right? So therefore this U is you need to calculate that U only. The U is equal to of only epsilon at 10th avutundi, 9 into 10 power minus 12 avutundi, and this E naught square will be equal to, this E naught is 100 here, that will be equal to 10 power 4 avutundi. Therefore you can calculate this, anything is missing. So 10 power 4 into volume. So volume is how much? Volume is 100 into 10 power minus 6. So this will be like 10 power 100 into 10 power minus 6. So please do this calculation. You will get the answer as this U is equal to 4.5 into 10 power minus 12. 4.5 into 10 power minus 12. That is the answer for this question. If you do that calculation, you will get that answer, right? Clear? So that is the answer for this. Next one, from the gravitation, the question is find the difference of weight of body from the surface of earth to at a depth of r by 4 from the surface of the earth. If its weight on the surface of earth is 400 newtons, so surface మీద weight 400 newtons ఉంది. Now we have to find the body weight at a depth of r by 4. There are some factors which will affect the gravity. One is height, other one is the depth, and one more is the rotation. So due to depth valla, this gravitation can be written as G dash is equal to G into 1 minus D by R, right? Remember the formula, right? So you could say this gravity at the depth can be written as G dash is equal to G into 1 minus D by R. 1 minus D is how much? R by 4. So R by 4R. R by 4R. Therefore this G dash is equal to G of 4R minus R can be written as a 3R by 4R, right? So this one get cancelled. Therefore G dash is equal to 3G by 4. If I multiply with the M here, so M into M here, you could say this M G dash will be equal to, or W dash will be equal to what I can write here. So which will be equal to 3 by 4 into mg. Mg is already 400. So this 4 and this 400 will be cancelled. That will be equal to 300 Newton. So that is answer for this question. Right. So please keep this formula in your mind for next exam. So that G dash is equal to G of 1 minus D by R. Clear? And there is a one more formula according to the side, that G dash is equal to G of 1 minus 2H by R. 1 minus 2H by R, that is for this height. This formula won't be used here. So this G dash is equal to G into 1 minus 2H by R, that is for the height. And there is a one more formula, that is this G dash is equal to G minus R omega square cos square into lambda. Right. So that is for, so G dash is equal to G minus R omega square cos square lambda. Right. So this is the formula for the rotation. So please keep it also in your mind. All these three formulas will affect the gravity. Right. Next one. The forbidden energy gap of a semiconductor material is 2.1 electron volt. The maximum wavelength of photon of sodium light is required to create a whole electron pair is nearly. So this is the valency band of a silicon, this is conduction band of silicon. So valency band lo ఉన్న electrons conduction band లోకి ట్రాన్స్ఫర్ అవ్వాలి అంటే you need to supply some energy. ఆ ఎనర్జీని త్రూ హీట్ సప్లై చేయొచ్చు, త్రూ పొటెన్షియల్ సప్లై చేయొచ్చు, ఆర్ త్రూ లైట్ అయినా సప్లై చేయొచ్చు. Here we are supplying that energy in the form of a light. So therefore the photon energy should be equal to that Fermi energy gap. That photon energy can be written as Sc by lambda. That Fermi energy can be written as Sc by lambda, right? So that will be equal to Sc by lambda will be equal to this much. How much should be equal to 2.1 or energy gap. Therefore this Hc can be written as a 1240 by the lambda should be in angstroms here. So lambda into lambda should be in nanometer. So 1240 by lambda in nanometer will be equal to 2.1 electron volt. Here also this will be now electron volt. So therefore you should get this lambda is equal to 1240 by that will be equal to 2.1. So if you do this calculation, you will get the answer as 5904 angstroms. So this is answer for this question. Clear? So that is from this not photoelectric effect. It is from semiconductors, right? So there is a one more question here. The question is, a water film is made between two straight parallel wires of length 10 centimeters separated by 5 millimeter from each other. If the distance between the wires is increased by 2 mm, how much work will be done? Surface tension for water is 729 per centimeter. Right? So this length is 10 and initial this gap is how much? 5 mm. Now that is increased by 2 mm. Now you know, like here this work done will be equal to, right, this work done will be equal to what? Work done will be equal to S into delta A, surface tension into change in area. Right, here this work done will be equal to surface tension into change in area. Surface tension into change in area. Therefore you could say this work done is equal to surface tension is how much? This will be equal to 72 dyne whatever. Right, one second, I'm just keeping everything in CGS. So delta A can be written as, so delta A will be equal to length into change in that this width, so L into dx. Since it is a film, you could say into 2. Therefore you will get, if you do this all the calculation here, into right, so that's it. 72 is the surface tension, L into dx is the area, into 2 because of film, so it will have two surfaces. Therefore this work done will be equal to, if you do all the calculation, you will get as the 288 ergs. Right? And one more thing here, you have to convert this into what? This will be like 2 millimeter. You have to convert it into centimeters. So that will be equal to 0.2. So if you do that, you will get W is equal to 288x. Clear? Next one. So a bike of mass 300 kg is taking a turn on a banked road of radius 100 meter and banking angle is 37 degrees. If the coefficient of static friction is 0.25, then the maximum speed with which car can negotiate the turn safely is. right? So therefore here especially this banking concept law, there are two formulas. One is V is equal to under root of rg tan theta, and one more is V is equal to under root of rg you could say mu plus tan theta by rg, mu plus tan theta by you could say 1 minus mu into tan theta. So these are the two formulas in the banking concept for the safest velocity. The first one is for the smooth surface and the second one is for the rough surface, right? So I'm not gonna explain this how we get these formulas here because this video will be lengthy, right? సో ఇన్ కేస్ నేను ఇక్కడ ఫార్ములాస్ అని ఎక్స్ప్లెయిన్ సో ఆ డెరివేషన్ చేస్తే వీడియో లెంతీ అయ్యింది. ఇఫ్ యూ వాంట్ ద డెరివేషన్ ప్లీజ్ కామెంట్, సపరేట్గా చేస్తా, రైట్? సో ప్లీజ్ సబ్స్టిట్యూట్ ఆల్ ద వాల్యూస్, యూ విల్ గెట్ ద ఆన్సర్. క్లియర్? మూవింగ్ టు ద నెక్స్ట్ అండ్ కీప్ దిస్ ఫార్ములాస్ ఇన్ మైండ్ ఫర్ యువర్ నెక్స్ట్ ఎగ్జామ్స్. ఎవరికైనా ఈ ఫార్ములాస్ ఎలా వచ్చాయో కావాలి అంటే సో ప్లీజ్ కామెంట్ చేయండి. I will explain separately for minimum 10 minutes or not 10 minutes, it may be take 5 minutes. Clear? Do this, substitute this values, you will get the answer. And one more thing is this one, the question is from this electrostatics. The question is two small identical conducting spheres A and B with equal and opposite charges Q on each other attract with a force of 64 Newton. A third identical uncharged conducting sphere is successively brought in contact with the two spheres and removed to infinity. The new force between them is, right? So let's say there is a charge here and there is a one more charge here B, right? One body is A, other one is body B. It is having a charge as Q and it is having a charge as a minus Q. Let's say the distance between them is R. Now this force can be written as, this force is equal to K, you could say Q1 Q2, you could say Q1 is Q and Q2 is also Q, you could say KQ square by R square. That is a force, right? Now we are bringing a one more third charge in contact with this. Let me say this is A, and I am bringing a one more uncharged here which is C. Bringing a one more uncharged here, that is the C. Both are should be identical, rendu identical avvali. Ikkada nenu okati peddaga rasanu, okati chinnaga rasanu, so please excuse for that. So this is having a charge of Q but it is not having any charge, therefore this charge will be distributed equally between them. So finally the charge on this A will be equal to Q by 2 and the charge on this C will be also equal to Q by 2. Then tarvata malli C ni we are bringing in contact with this B, right? One second. So we are bringing this C in contact with this Q. Now ఈ C ని B తో కాంటాక్ట్ లో చేస్తున్నప్పుడు it is having a charge of Q by 2. It is having a charge of Q by 2 and it is having a charge of minus Q. Therefore this total charge will be distributed in between them equally. Therefore you could say charge of B or charge of each one can be written as, charge of each can be written as, that will be equal to sum of these two. So Q by 2 minus Q, right? That will be equal to minus Q by 2. That will be equal to minus Q by 2 by 2. That will be equal to minus Q by 4. So minus Q by 4, that is a charge on the B as well as that will be also charge on this C. That is a charge on this B as well as the charge on the C will be equal to minus Q by 4 as well as minus Q by 4, right? Now what is the force here? What is the force of attraction between them? F dash will be equal to K here. So this is A and this is B. The final charge on this A is Q by 2. The final charge on this A is Q by 2 and this final charge on this B is Q by 4, right? Q by 4. So therefore this F dash will be equal to, this can be written as a KQ square by 8. This will be R square here. So KQ square by 8 R square. Therefore the final step is F dash will be equal to F by 8. F dash will be equal to F by 8. Clear? So therefore you could say this F dash will be equal to, F is how much? 64 by 8. That will be equal to how much? 8 Newton. So that is answer for this question. So please keep all these logics in mind, right? Next one. So when 10 ampere current is flowing in an induction coil, then the magnetic energy stored in the coil is 1 joule. The self induction of the coil is, this is a direct formula. the energy stored in this inductor will be equal to U is equal to half into L into Y square, right? U is equal to half into L into Y square. The energy is 1. The energy is 1, therefore half into L into Y square. What is L here? We don't know this L, and this I can be written as this 10. I can be written as 10, so this will be equal to 10 square. Therefore this L is equal to 2 by 100, right? L equal to 2 by 100, that will be equal to 20 millihenry. So that is answer for this question. So please carry forward this formula for your next exam. So U is equal to half into Li square. So please carry forward for your next exam, right? So next one is this one. A convex and concave lens of focal length 10 cm and 20 cm respectively are kept in contact with each other. Find the focal length of the combination of lenses, right? You know, when the two lenses are in contact, you could say this F equivalent is equal to, or 1 by F equivalent is equal to, you could say 1 by F1 plus 1 by F2. 1 by F1 plus 1 by F2, right? One is convex lens, other one is a concave lens. Therefore 1 by F equivalent, 1 by F equivalent will be equal to, one is positive, one will be negative, because concave lenses will, focal length will be negative and convex lenses will have a positive focal length. So a convex lens is 10 cm, therefore you could say 1 by 10 minus 1 by 20. So you can easily do this for the calculation. What you have to remember is focal length of convex. So focal length of convex will be positive and focal length of this concave will be negative. So this is only one thing that you have to keep in mind. Focal length of concave will be negative. This is the only one thing that will be keep in mind. So remaining is a calculation. You can easily do that. So please do them, right? Next one. So if the ratio of number of moles of hydrogen gas to oxygen gas is 2, the ratio of total translational kinetic energy of hydrogen gas molecules to that of oxygen molecules at 20 degrees Celsius is, right? The temperature is same. The temperature is same here. Therefore, you know, you could say this energy, right? So this kinetic energy can be written as, half into, or you could say 3 by 2 into kBT, right? Sorry. This kinetic energy Ke will be equal to 3 by 2 into kBT. 3 by 2 into kBT. Sorry, one second. This kinetic energy will be equal to 3 by 2 into kBT, right? So if you convert this kinetic energy is directly proportional to this number of moles. Therefore, you could directly say that this will be equal to 2 is to 1. The answer is 2 is to 1, right? That is, what is it? The kinetic energy of hydrogen to kinetic energy of this oxygen. Clear? So please keep this formula in mind for your next exam. This Ke is equal to 3 by 2 kBT. Next one is this one. A body of weight 250 Newton is hanging on a spring balance which is suspended from the ceiling of an elevator at rest. Now elevator starts accelerating upward with an acceleration of 2 meter per second square. Then the reading of a spring balance when the body comes to an equilibrium relative to the elevator is, right? So here since this frame is moving up with an acceleration of what? With an acceleration of 2 meter per second square. This this elevator is moving up with an acceleration of 2 meter per second square. Therefore, since this frame is moving up, it is an inertial frame, right? So therefore, there is some pseudo force will be acting in this direction on this block, on this bob or else. So that will be equal to what? The pseudo force will be equal to mass of this, right? So mass of this into acceleration, that will be nothing but m into 2. Therefore, now we could say this tension. Now we could say this tension is equal to this mg plus m into a. This tension is equal to mg plus m into a. Both are same m. So mg plus m into a. Therefore, this T is equal to, you could say mg plus m into a. What we have to calculate here, then the reading of the spring balance will be how much? So you could say this can be written as m, right? So mg is how much? 250. This is 250 plus, what is m here? You could say if I divide with the 10, it will be equal to 25. So 25 into 2. So therefore the answer for this tension is equal to 300 Newton. So that is the answer for this. So please keep this formula also in mind. pseudo force, right? Next one, when a photon of wavelength 400 nanometer is incident on a metal surface, the electron emission takes place. The stopping potential to stop electron is 1.5 volt. The work function of the metal is. You can solve this problem by using this Einstein equation, right? So what is the Einstein equation? You could say Einstein equation is energy of a photon is equal to work function plus kinetic energy, and that kinetic energy can be written as E into V. Now you could say this EPH can be written as energy of a photon can be written as C by lambda, right? So since it is in nanometer, you could say this 1240 by this can be written as a 400 will be equal to pi plus E into this voltage, right? Here the stopping potential is 1.5, so this will be equal to 1.5 already, so this can be written as 1.5 into EV, right? So you could directly do this problem. So this pi is equal to, you could say 1240 by 400, right, minus 1.5 into E into V. So do this calculation to get this answer. I'm not doing this calculation because నేను చేస్తే ఈ వీడియో అంతా లెంతీగా ఉంటుంది, రైట్? మళ్ళీ వీడియో లెంత్ తగ్గించండి అని చెప్పేసి మీరే అడుగుతారు. సో నాట్ డూయింగ్ ఇట్. So EPH is equal to pi plus EV. So just do this calculation. So 0 0 get cancelled, and this 40 10 times you could easily do that, fourth table, right? Next one, the number of electrons flowing per second in the filament of 100 volt bulb operating at 240 volt is. So since you know power formula in terms of voltage and current, so P is equal to I into V, right? You could say now current can be written as power by voltage, right? So therefore this I is equal to, what is the power here, 100 by voltage is how much, 240, right? So P is equal to I into V, therefore I is equal to P by V, and this I can be written as Q by T, or I could also say that this can be written as NE by T. NE by T will be equal to 100 by 240, right? Now you could say this per second only, therefore you could say this N is equal to, you could say 100 by 240 into 1.6 into 10 power minus 19. All are just calculations, right? Easy paper, all are calculations. So do this, you will get this answer as this 2.6 into 10 power 18. That is what we get, right? So please keep this formula in your mind. Next one, when the momentum of a body is increased by 200%, then its kinetic energy will be increased by what? You know the relation between this kinetic energy and this potential. You could say this kinetic energy is equal to, this kinetic energy will be equal to P square by 2m, right? P square by 2m. Now when the momentum of a body is increased by 200%, nothing but it is increased by 2, nothing but the total will be equal to what, 3. So you know this kinetic energy is directly proportional to P, right? So sorry, P square. Now you could say kinetic energy final by kinetic energy initial, right, will be equal to how much? This will be equal to, sorry, 1 second. So this will be 3 times, final will be 3 times, final momentum is 3 times of initial momentum, therefore that will be equal to 9p by p. So will be cancelled out, therefore you could say this final kinetic energy will be equal to 9 times of initial kinetic energy. You have to find the fraction or percentage change, therefore you could say this delta k by k into 100 will be equal to 800. If you do this calculation, 900 which will be equal to 9 minus 1 by 1, so that will be equal 9 minus 1, which will be equal to 800. So 800%, right? That is the answer for this question. Already formula me gurtunnade, hope everybody has done this, right? So next one, this one. So pressure inside a liquid drop is greater than the pressure outside by an amount of 2s by r, where s is the surface tension of a liquid and r is the radius of liquid drop. When 8 such identical drops combined together become one single drop, then the pressure difference between the inside and outside the drop will be equal to, right? So since it is a liquid drop, you could say the pressure, excess pressure is a 2s by r, right? So now there are 8 bubbles, that 8 drops are becoming into one drop, therefore this total volume will be equal to the single volume, therefore 8 into 4 by 3, right? 8 into 4 by 3 pi r cube will be equal to 4 by 3 into pi capital R cube, right? So this 4 by 3 pi, 4 by 3 pi will be cancelled. Now this can be written as this R is equal to 2 into R. That capital R is equal to 2 into R, or let me say this is R dash because this is given as R here. Here this will be only 2R, right? So therefore now what is the excess pressure formula? You could say this delta P is equal to 2S by R. The delta P will be equal to 2S by R, where is nothing but R dash. Therefore this can be written as a 2 into S is S only by R dash can be written as a 2R. So therefore you will get the answer as S by R. You will get the answer as S by R, right? Next one is the matching. So match the list. So here is the question, right? So we have to use this question by using this Ampere law. So one is magnetic susceptibility, other one is absolute temperature. You know, when this temperature is increasing, the susceptibility will decrease. So therefore you can go with the A is 2, A will be 2, A will be 2. Therefore you can eliminate this B and D. You can eliminate this B and D. Now we have to find out a magnetic field along y-axis, and along x-axis the distance from the for this cylindrical pipe. Cylindrical pipe is nothing but this like a hollow cylinder. Hollow cylinder ki lopala magnetic field emi undadu. So that will be start from only or that will start only from this radius. So therefore you could match B with the 3. So here B3, B3. So again there is A and C. And what about this last option C? So Y is equal to magnetic field. Again along y-axis there is a magnetic field, but along x-axis there is cylinder, solid cylinder. So solid cylinder ki lopala untadi, baita untadi. Lopala B will be directly proportional to R. Inside B is directly proportional to R, but outside is B is inversely proportional to R. Therefore the first option will be for the third option. For option C, first one will match. Therefore the option is C here, right? So A will match with the 2, B will match with 3, and C will match with 1. So therefore the option is C for this question. Clear? So check it. Next one, theory question. A metallic disc connected to a rod oscillates freely like a pendulum. If a now magnetic field is applied in a horizontal direction, so that pendulum now swings through the field, the pendulum will be keep oscillating with this old time period, keep oscillating with the smaller time period. We have to understand whether this time period will be remain constant or that will change. సో ఇప్పుడు ఇక్కడ మ్యాగ్నెటిక్ ఫీల్డ్ క్రియేట్ చేస్తే ఈ డిస్క్లో ఫ్లక్స్ చేంజ్ అయ్యేది. సో ఫ్లక్స్ చేంజ్ చేయడం వల్ల ఈఎంఎఫ్ వచ్చేది. దేర్ఫోర్ ఈఎంఎఫ్ రావడం వల్ల ఇండ్యూస్డ్ కరెంట్ వచ్చింది. ఈ ఇండ్యూస్డ్ కరెంట్ నువ్వు బయట నుంచి అప్లై చేస్తున్న మ్యాగ్నెటిక్ ఫీల్డ్ అపోజ్ చేస్తూ ఉంటుంది. ఫర్ దట్ విల్ అప్లై సమ్ ఫోర్స్ ఆన్ దట్. సో దేర్ఫోర్ ఏమైంది అంటే స్లోగా అది మొత్తం కూడా స్లోగా ఆగిపోతూ ఉంటుంది. సో దేర్ఫోర్ దట్ కంటిన్యూస్లీ స్లోస్ డౌన్ అండ్ కమ్ టు రెస్ట్. సో ఈ బయట ఉన్న ఎక్స్టర్నల్ మ్యాగ్నెటిక్ ఫీల్డ్ని అపోజ్ చేసే ప్రాసెస్లో వెలాసిటీ అంతా, దాని స్పీడ్ అంతా తగ్గిపోతూ ఉంటుంది. therefore that slowly comes down. So finally ga rest వచ్చింది. therefore the option for this question is this one, option D, right? Next one again easy one. So given below are two statements. Statement 1, dimension formula of this Planck constant is ml square t power minus 1. Dimension formula of this bulk modulus is ml power minus 1 t power minus 2. We have to check these formulas. You know, Planck constant can be written as E is equal to SE by lambda, right? So from that we could easily calculate that Planck constant E is equal to SE by lambda. E equal to SE by lambda, energy is equal to SE by lambda. Energy can be written as ml square t power minus 2, right? And this lambda can be written as, lambda is nothing but meter, so therefore that will be L will be equal to H into C. C can be written as L by T, right? So therefore this L and this will get cancelled, and this will be cancelled. This t power minus 2 here and t here. Therefore this H will be, or H will have a dimensions of ml square t power minus 1. Therefore the first one is right. The first one is right. What about second one? Dimension formula of the bulk modulus. You know, bulk modulus formula, remember, right? The bulk modulus formula is, you could say, B is equal to minus delta P by delta V by V. Delta V is a volume and V is also volume. So therefore this denominator will do not have any dimensions. So now the bulk modulus will have a units of pressure only. You know, pressure can be written as pressure is equal to force by area. So force can be written as ml t power minus 2 by area can be written as L square. Therefore the dimensional formula is ml power minus 1 t power minus 2. Therefore the both are right. Option A statement, sorry, both the statement 1 and statement 2 are correct. Right, both are correct. That is the answer for this question. Next one. A body is projected vertically upward with a certain speed from the top of a tower, reaches the ground in time t1. If it is projected vertically downward with the same speed from the same point, it reaches the ground in time t2. The time required for it to reach the ground if it is dropped from the same point and projected horizontally with the same speed. Right, so ఇలా పైకి త్రో చేస్తున్నాం విత్ ద వెలాసిటీ v నాట్ అండ్ కిందికి త్రో చేస్తున్నాం విత్ ద వెలాసిటీ v నాట్. సో పైకి త్రో చేస్తున్నప్పుడు టు రీచ్ ద గ్రౌండ్ దట్ ఈస్ టేకింగ్ అ టైమ్ యాజ్ t1, కిందికి త్రో చేస్తున్నప్పుడు దట్ ఈస్ టేకింగ్ అ టైమ్ యాజ్ t2. రైట్, సో నౌ ఇలా కిందకి జస్ట్ ఫ్రీగా వదిలేస్తున్నాం, అలా వదిలేస్తున్నప్పుడు దట్ ఈస్ టేకింగ్ అ టైమ్ యాజ్ వాట్ t, లెట్స్ సే t. రైట్, సో పైకి త్రో చేస్తున్నప్పుడు t1, కిందకి త్రో చేస్తున్నప్పుడు t2 అండ్ ఫ్రీగా డ్రాప్ చేస్తున్నప్పుడు t. And we have to find the relation between all this. Now ఇలా top of the tower and throw చేస్తున్నప్పుడు you could say minus h is equal to, right, so this is the only displacement, so minus h is equal to, you could say ut, because u will be positive, minus half into g into t2, right, sorry my mistake, t1, so here also half into g into t1 square. This is, let's say, equation 1. Top of the tower పై నుంచి టవర్ నుంచి పైకి త్రో చేస్తున్నాం అండ్ కింద త్రో చేస్తే ద డిస్ప్లేస్మెంట్ విల్ బి సేమ్ అగైన్, దట్ ఈస్ మైనస్ హెచ్, బట్ హియర్ ద వెలాసిటీ ఆల్సో మైనస్ u ఇంటూ t2, రైట్, minus the gravitation will be, sorry, g will be also negative, so therefore of t2 square, right, of g t2 square. So let's say this is equation 2. Now you could say this minus h, you can equate these two equations. One second. You can equate these two equations. Therefore if I equate it, u t1 minus half into g into t1 square, right, will be equal to minus u t2, right, minus half into g into t2 square. So bring it all the u terms one side and all the g terms one side. Therefore you could say, if I take u out, I could say t1 plus t2, t1 plus t2 will be equal to, this can be written as half into g into t1 square minus t2 square, right, so this t1 plus and this cancel, therefore you get u is equal to half into, right, half into here, this can be written as g into t1 minus t2. If you substitute this value here, you get this h is equal to half into g t1 t2, half into g t1 t2, right, half into g t1 t2, that is what we get h here. And if I drop it freely, you could say, when we drop it, you could say this h is equal to half into g into t square, right, half into g into t square. If you drop it freely, what is h here, half into, the h is half into g into t1 t2, right, will be equal to half into g into, this can be written as t square, of g get cancelled, therefore you get this t is equal to under root of t1 t2, under root of t1 t2, that is when we drop it from the top of the tower, you could say this t is equal to under root of t1 t2, right. Now one more case is there, we are just projecting horizontally గా త్రో చేస్తున్నామంటే vertical గా ఇనిషియల్ వెలాసిటీ అంతా 0 అని, that is the same case of dropping, therefore you could get both are will be same. So horizontal గా project చేసిన as well as drop చేసిన, that will reach in the same time, therefore under root of t1 t2 and under root of t1 t2, right. That is the answer for this question. Next one, this one. So in an Millikan's experiment, an oil drop of radius 2 into 10 power minus 6 meter, density is 900 kilogram per meter cube, is held stationary between the two condenser plates 1 centimeter apart and kept at a potential difference of 1.5 pi kilovolt. If air effect is neglected, then the number of excess electrons that carried by the drop is, so it is carrying excess electron, therefore it will have negative charge, right, it will have a negative charge, that will have a negative charge, and negative charge is how much, that negative charge will be equal to q into ne, which is nothing but that q, or else let me say that q, let me say this is q only, negative charge, and this q is equal to n into e, this is negative, please keep that in mind. Now this is a positive terminal, this is a negative terminal, so this electric field will create from positive to negative, right? Since it is a negative one, దీని మీద ఇక్కడ వెయిట్ కిందకి యాక్ట్ అవుతూ ఉంటే సో దిస్ ఎలక్ట్రిక్ ఫీల్డ్ వల్ల వచ్చే ఫోర్స్ ఇలా పైకి యాక్ట్ అవుతూ ఉంటుంది, రైట్? సో దట్ ఫోర్స్ ఇస్ నథింగ్ బట్ క్యూ ఇంటూ ఈ. ఇది ఇక్కడ రెస్ట్లో ఉంది అంటే యూ హ్యావ్ టు ఈక్వేట్ దిస్ టు, దేర్ ఫోర్ దిస్ ఈక్వేట్ దిస్ టు హియర్ క్యూ ఈజ్ ఈక్వల్ టు ఎమ్ ఇంటూ జీ. Q equal to m into g. Here Q can be written as n into e, and E can be written as v by d. From this potential and electric field concept will be equal to what is the mass here. The mass is not given, density is given, and volume is given. So mass is density into volume 4 by 3 into pi r cube into g, right? So please do this calculation to get this n. So please do it, right? Don't leave the calculation, do it, right? So that is the only one logic. So please keep this formula for your next exam. Q is equal to m into g. So ఈ వెయిట్ ని ఈ ఎలక్ట్రిక్ ఫీల్డ్ వల్ల వచ్చే ఫోర్స్ బ్యాలెన్స్ చేయాలి, రైట్? నెక్స్ట్ వన్, this one. In an LCR circuit as shown in the diagram, the supply voltage is dash volt, right? So you know this can be written as, so here this is, if I draw the phasor diagram, this is VL, this is VR, and this is VC. So therefore if I write the net voltage, can be written as net voltage is equal to, or supplied voltage is equal to under root of you could say this is VR whole square. This is VR whole square plus you could say this is nothing but VL minus VC. VL minus VC, because this VL is more and VC is less, therefore this V is equal to under root of. So what is the VR here? That can be written as, you can directly say the answer, right? You could get it as a 500. This V is equal to 500. Choose step వచ్చింది direct గా, because this is 400, this will be equal to 300 under root of 400 and 300 square. Under root of 400 square plus 300 square will be equal to 500. Therefore V is equal to 500 volt. So you can directly say that. That is the question. So next one is this one. A particle moving in a straight line, its velocity v with the time t is given as, this v is equal to t square minus 1 meter per second. The distance travelled by the particle between this t is equal to 0 to t is equal to 2 seconds is, that was the distance that you have to calculate. You need to calculate the distance, it is not the displacement, guys. You need to calculate the distance, only positive, not the negative. So therefore here this v is equal to, this will be equal to t square minus 1. So now if the velocity will be 0, right? So you have to find this 0 to 2, but if ikkada mundu velocity ekkada 0 ayithe kanukovali, right? So velocity ekkada 0 ayithe kanukonde, you could say this t is equal to, what is the t is equal to, if the velocity is equal to 0, so t is equal to 1 second. Therefore that is going to be stop at 1 second and again that will come back, right? So ikkada poyi 1 second daggara agi malli that will come back, right? So therefore I need to find out this distance now. Just I could say this dv is equal to t square minus 1, sorry, v is equal to, I could say it as a dx by dt. Dx by dt will be equal to, I could say d square minus 1. Now this x will be, or integration of dx will be equal to integration of this t square minus 1. So t square minus 1 into dt from where to where, from 0 to 1 plus integration from this 1 to 2 from t square minus 1 into dt, right? So you need to calculate total. So if you do this, you will get the answer, right? So do it, you will get it. So you will get this value as minus 2 by 3 and you will get it as plus 4 by 3, right? So you will get it as a, so how much you will get? One is minus 2 by 3, other one is plus 2 by 3. So please do this calculation once, how much you will get. What much you get? It is 0 to 1. You will get as a 2 by 3 and 4 by 3. Right? 2 by 3 and 4 by 3. Of course you will get it as a negative, but you have to take it as a positive only, because you have to calculate only distance, right? Therefore, so 2 by 3 and 4 by 3, that will be equal to 2. That's the answer for this question. 2 meter, therefore it is centimeter, right? So that will be equal to 200 centimeter. If you do this calculation, you will get it as a minus, but it is only distance, right? Therefore you have to take it as a 2 plus here, right? Or else you have to take it as a modulus of these values. Clear? Next one. This question is easy. So 6 particles each of mass 1 kg, 2 kg and 3 kg, 4 kg, 5 kg and 6 kg are kept at the vertices of regular hexagon of side 1 meter. The moment of inertia of the system passing through this center and perpendicular to its plane is easy question. So there is a 1 kg here, right? This is 1 kg and this is 2 kg and this is 3 kg and this is 4 kg. This is 5 kg and this is 6 kg. Now from this axis all are at a same distance, right? Therefore you could say the total moment of inertia about this axis can be written as mr1 square plus mr2 square and so on. Therefore this m1 plus m2 plus, you can take out this r1 square in common, so m1 plus m2 plus m3 plus m4 plus, or here in the calculation what is again, so 1 2 3, so 1 2 is 3, 3 3 is 6, 10 15 16, so you could say this is 16. So 16 into 1 square, therefore the answer is 16, that is I is equal to 16 kilogram meter square, right? That's the answer for this. This is the last one. The question is a circular coil having a 50 turns and a radius of under root of a 7 by 22 meter carrying a current of 1 milliampere is placed in a uniform magnetic field of 2 Tesla such that plane of coil is perpendicular to magnetic field. The work done in turning the coil is, this work done can be written as, this work done is equal to, so you could say this is U final minus U initial, therefore this W is equal to, this U can be written as, or you could say it is nothing but minus MB, right? Minus MB cos theta minus of minus plus MB cos theta, right? So therefore if you substitute these values here, you will get the answer. You will get it as a 2 MB if you substitute the values. Sorry, if you substitute these angles, you will get as a 2 MB, and therefore this W is equal to 2 into, this can be written as I into A. So I is here, what is I? I is 1 milliampere, so you could say 10 power minus 3 into area can be written as a pi r square. So pi into r square can be written as, this can be written as a 7 by 22 here into number of turns are 50 into magnetic field is 2. So do this calculation to get the answer, right? If there is any doubt, you can comment. I will give you the reply. Thank you.